Hi everyone. In this video, we're gonna learn how to test a claim about a proportion. Before we get into all the steps and the mechanics of how you do that, I'd like to just take a few minutes and really talk about what it means to make a claim and to test it. So the first thing we're gonna do is I'm just gonna pose a question here, or a statement, in fact, and we're told that the CDC, the Centers for Disease Control, has said that the flu rate this year is 8%. 8% of the population has the flu. Well, I've actually seen a lot of people in my town, a lot more than 8%, I think, that have the flu. So I'm going to claim that the flu rate is higher than that in my town. So all a claim is it's a statement about something that you believe to be true. But of course, we can't just accept everybody's claims. People can make claims about anything, and we see that all the time in commerce, or for example, pharmaceuticals. A drug company can claim that a certain drug is going to improve your headache. You won't get headaches 98% of the time, or something like that. And so, do we just accept those claims? Well, no, we like to hope that statisticians are out there testing the validity of those claims. Now, whether or not something is true is difficult in statistics, so we don't often come up with 100% certainty. We come up just like with confidence intervals, we come up with certain range, and we have a certain percentage of confidence in that value or that claim or whatever. So the idea is going to be the same here. So the first thing we need to do is approach this sort of like you would in a science class or something, in a biology class. You're gonna do a lab or something. And so how do you start with a lab? You usually make a hypothesis. And in this case, our hypothesis, one of our hypotheses anyway, is going to be the claim. I'm going to claim that the flu rate is more than 8%. And how do I do that in statistical language? Well, it is the letter P, obviously, and higher, which means greater than 8%, 0.08. And so my hypothesis is that the percent of the population in my town is greater than 8%. And the reason I'm using a P, not a mean, is because this is categorical data. I'd go out and ask people, do you have the flu? Have you had the flu? And it's a yes, no answer. So you're dealing in percentages rather than means. Well, quite often when you have a hypothesis that's hypothesizing something different, you have to have that null hypothesis where it is that whatever exists is is unchanged. All right. So whatever it is you're claiming is not actually, there's not enough evidence to support that what it currently is incorrect. So that's what we call the null hypothesis. And if we can't throw out the null hypothesis, then we really can't accept the alternative hypothesis. And that's the way a hypothesis test works. So what do we do first? So the first thing we're going to do is we're going to assume that our flu epidemics are normally distributed, that the population throughout the country is 8% in most towns. There are going to be some towns out here with a very high percentage of flus. Maybe out here there's going to be some towns where nobody has the flus. And we're testing this. We're claiming that our town is somewhere out here, high, in the right tail. We are going to be focusing on the right tail. All right. And of course, with normal distributions, we have to think about standard deviation and spread and how far out is my town. All right, is it way out here, way out here, so that the chances of that actually happening is so unusual that there must be something going on in my town. So what are we going to do? We're going to have to look at some data. As with most statistical claims, you have to do a study, and that means you have to get a sample. I'm not going to go ask everybody in my town. So I'm going to get a sample. Let's say I've gone out and I've asked 150 people in my town whether or not they've had the flu, and I get an answer of 17 people have had the flu out of the 150. So what is my sample percentage of flu? That's the reason for the hat. That just means the sample. You do that on your calculator, you're going to get 0.113, or about 11.3% of this sample had the flu. So that's already looking good. It's making it certainly seem like my claim might be valid. My sample is certainly much higher than the average flu rate for the country. But is it enough? Is it enough evidence? Is it a big enough sample? Is it strong enough to still accept that claim? Well, what do we do? Well, we need to find some way to put this on our normal distribution curve, figure out where exactly is that. I know it's somewhere out here. If here's 8%, 11.3% must be somewhere out here, but exactly how far out? Well, what do? We find a z-score. Okay, and this is what we call a test statistic. It's just a z-score. We find a z-score so we know how far out we are. And we do that by taking the sample of 0.113, subtracting off the population proportion, which is 8%, and then we're going to divide by what is basically the standard deviation of this population, which is PQ divided by N. Let me undo that a little bit. And if you PQ was 0.08 times 0.92, because if P is 8%, then that means 92% do not have the flu, and our population size was 150. And I'll go through formulas in a minute, but basically that's just how we've been doing that since the beginning of the semester. That's just how you find a z-score. If you do that all on your calculator, you're going to get a z-score of 1.50, rounded to 2 decimal places because we're going to need to use our z-table. So where does that plot? Well, I'm going to put that right about here. It's about 1.5. Okay, so this is that test statistic here. It's just a z-score. Z equals 1.50. All right, and so how likely is that? Well, what is the chances of that happening? Of having 11.3% people in your town with the flu? So what we have to do is I want to figure out what is this area here? What is the probability? What's the percentage? Remember, area under the curve is percentage, probabilities. And this is what we call a p-value. All right, and how do I find that p-value? Well, we've been doing that as well for a long time. It's just equal to the probability that z is less than or equal to our 1.50. Oops, I apologize. It's not less than. We are on the, it is greater than. We want above 1.50. And that's equal to 1 minus the probability that z is less than or equal to 1.50. Hey, doggies. Sorry. Time to pause. Seem to make my videos during dinner time. All right, so if you go to your z-table and you look up 1.50, you are going to discover that about 93% below 0.9332. So that means 0.0670, approximately 6.7%, is above this test statistic. So here we have 0.0670. All right, well, the question now becomes, is that far enough out to accept the claim? Normally, we like things within 5%, but do we want 5% significance, or do we want to be, or the flip of that would be like 95% confident? But rather than using confidence levels, we talk about significance levels because we're in the tails as opposed to the center of the where we were with the confidence levels. So that's why we need some sort of frame of reference. So we do what's called a significance level. We have, because again, we can't say for certain. We just have to be comfortable with a certain level of certainty. So we use this sigma level, this sigma symbol. I'm sorry, alpha. Sigma is for standard deviation. Alpha to represent our significant level. And normally we have like a 5% level, right? Sometimes you can have a much smaller level of confidence, which means, or level of significance. Sometimes you can have a bigger level of significance. What do those mean? Well, this is the most common one here, 5%, because we're so comfortable with the idea that anything outside of 95% or something that occurs only 5% of the time is very unusual. And so if this is happening and it's extremely unusual, that there would be this big of a percentage of people with the flu, maybe something is going on in my town. Maybe the claim is correct. So that's really what we're doing here. So let's just start here with this 0.05. Well, sigma is an area under the curve. So somewhere in here there's a sigma. It's the area under the curve. In fact, it equals 0.0500. And again, you know from finding critical values, if you've got 5% to the right, you've got 95% to the left. So if you go ahead and look that up, you're going to find that for a significance level of 5%, you have a z-score of 1.645. And I just write the little letter C here to represent meaning it's a critical value. It's what we've decided as our level of significance. So we call this a critical value, and it is where z equals 1.645. And we can see that it's farther to the right than 1.50. So here's my alpha space. There's 5%, and the p-value is 6%. So we're really not in that space. This isn't so unusual. If it could just be a fluke. I could have just picked a very high percentage. It's not enough. It's not high enough to feel certain that my town is overall higher than the national average. All right. So in other words, in this case, we cannot. Is the claim true? Is this claim true? No, it's not. It's not enough evidence to say the claim is true. It doesn't mean for certain that we don't know whether or not it's true. It just means there's not enough evidence to say that that it's true. So, but what happens if we change that level of significance? So let me pick a different color here. Let's say here we go up to 10%. All right, now what happens? Well, if we come out here a little further, we make our critical value farther out, we have more uncertainty. In fact, all this area here is now up to 10%. Okay, where it's green, our alpha is equal to 10%. Well, what's that z-score? If you go look at your z-table, you will see that at 10%, our critical value is 1.28. All right, and now you can see that this test statistic here, the one in pink, is now in this critical space, right? So at that level of significance, at 10% level of significance, we can say yes. We can say yes. There is something going on in my town. So it's all how much level of significance you are willing to accept. All right. So what does that mean? It means if we're willing to have a significance level at 10%, we can claim that the rate of flu is higher in my town than 8%, but only to a 10% significance level. At a 5% significance level, we cannot make that claim. All right, so how do we put this all together? Let's take a look at that. Actually, before I flip over, I just want to say what we say about the claim in this case. In this case, what we can say is because this in the green area, our our p-value is less than alpha when we're at 10%. So in other words, 0.0670 is less than 10%. Then we can do what's called rejecting the null. You reject the null. That means you can almost think of it like rejecting it, crossing it out. And if you cross that one out, then we have to accept the alternative. Because the way we've stated is one of these two has to be true. Either you're at the mean or it's greater than. So if you can reject the null, then there's enough evidence to accept this alternative hypothesis, which is the claim. All right. But if we use the lower level of significance, now what happens is our p-value is greater than the level of significance that we want. 0.0670 is greater than 0.05. So when that happens, we can't reject the null, or what we call it's double negative, but you fail to reject. You fail to reject the null, which means we can't draw that line through this null hypothesis. And so if you can't draw the line through this one, you can't rule that one out, then you can't for certainty accept the alternative. So that's what's happening here. So we're at the end of all of this, what our goal is to find out, are we failing to reject the null, or can we reject the null and accept the alternative? So let's go back and do this look at what we did in terms of actually all the steps. So let me close this out in this. And let's go down here. Let's see. Here we go. These are the steps now. Oops. These are the steps for doing a hypothesis test on a proportion. So let's turn that off. All right. So what are the steps? And I'm just going to quickly go through these with the problem we just did. The first step for this is to test a claim for a proportion. We'll, of course, do means next in the next video. So the first step, just like with confidence intervals, we've got 5 steps. If you follow each step, it's just going to fall right into place. The first step is to state your null and your alternative hypothesis. And your null is always going to be P equals something. It's always going to be an equality. In this case, it was 8%. And then your alternative is always going to be either greater than, less than, or not equal to. It's going to be an inequality. And for our problem that we just did, we looked at a greater than 0.08. And then you identify which one is in fact the claim. So this is the claim here. Sometimes the claim is the null, but not very often. And then the next thing we want to do is look at our sample information and find that sample. And our sample P was the 11.3. There was 11.3% of my sample that had the flu. Just like with confidence intervals, step 2, we need to check conditions. That just is making sure that we have at least 10, both 10 successes and failures. Right, and we know we did. I think there were 17 people who had the flu, so there's 17 successes, and the remainders, I don't know that off the top of my head, would have not had the flu, but you have enough of each event to be able to move forward. So step 3 is where the bulk of the work is. We determine the test type. Now I didn't talk exactly so much about that, so let me just close out and pull out another screen here. Let's see here. Okay, there's 3 different types of tests that we can do. We can look at a right-tailed test, a left-tailed test, a two-tailed test, or a right-tailed test. The one we just did was a right-tailed test because it was greater than. We were focusing on being above the mean. And as you can guess, if your claim is you're claiming something less than, you're going to be down here in the left tail, below whatever it is that the average is, or whatever the population is, and you're claiming that something's less than that, you're over here in the left tail. So alpha's in your left tail, and your z-score, your critical value, will be negative. Our critical value was positive because we were over in the right tail. In some situations, your alternative hypothesis is simply just not equal to. You're claiming that something just is not whatever the null is. You're not saying it's more than or less than. You're just saying it's not that at all. So that is less likely to happen. That's more difficult because what happens is your significance level here, alpha, has to get divided into 2 parts. Half of it's in each tail. So you end up having 2 critical values, one negative and one positive, and then you still find the test statistic the same way and plot it. But it's what happens because it's broken into 2 parts. These get moved out farther, and so your test statistic has to be really far out to be convincing enough to reject the null. Okay. But in all 3 of these cases, you still plot your test statistic, and wherever that might be, if it's not in the critical space, you fail to reject. If it is in the critical space here, you reject the null. Okay, so let's go back to our step. Okay, so on our problem here, we ended up having a right-tailed test. So in this step 3, the first thing you want to do is identify which tail type test you're going to do. And then on that, you're going to draw your normal curve, and then plot the following things. A is you're going to plot that test statistic. So you've got some alpha, and you're going to, the critical value. You're going to plot your critical value and your alpha. So that's what those are. Alpha is just your critical space. And then you're going to find your test statistic, and you do that by finding your z-score, wherever that might be. You've got some sort of test statistic here. And so then you plot that. And that one you have to use, this one is based on your sample data. So this was the one that worked out to be 1.50, and up here we had a critical value of, well, we had two of them, based on whether we used a level of 0.05 that had one critical value and 0.10 had the other critical value. Okay, after you've done that, then step 4, you find the p-value and you state your conclusion. And the p-value was just simply finding the area to the right or the left, depending upon which tail you're in. In this case, it's to the right. You're finding that area to the right of your test statistic. That is your p-value. And based on that, you state your conclusion. Are you going to reject the null because your p-value is less than your critical space? Or are you going to fail to reject the null because your p-value is greater than your critical space? Once you make that decision, you interpret that result. If we are rejecting the null, if we're rejecting the null and we're crossing it out, then there is enough evidence to support the claim, which is down here, the alternative hypothesis, that whatever your situation may be. In this case, it was that the flu rate, the flu rate is higher than 8% in my town. Okay. And so just to review that finally, in conclusion, if your test statistic is here in the critical space, like on this side here, you and your p-value is less than your critical space, so here the blue is less than the pink, then we can reject the null, which means we go up here, we cross it out, and we say there is enough evidence to support the claim, that's so on. And the other thing that can happen is when your test statistic is outside of your critical value, critical space. In other words, your p-value is larger than your significance level, you're going to fail to reject the null. In other words, you can't cross that out. You cannot accept this because you don't have enough support to cross that out. So there's not enough evidence. You'll never say with certainty, yes, the claim is true, or no, the claim is false. It's always about levels of evidence, and that is based on those significance levels. Okay, so go ahead and try some work. Good luck.